In this lesson, we're going to look at dividing radicals. When we're dividing radicals, we can divide them if the indexes are the same. If they are, it's very similar to what we did with multiplying radicals. We divide the coefficients, and then we divide the radicands. In this case, we have coefficients of 14 and 7. The degrees are equal. We have radicands of 10 and 5. So, what we can do is divide the coefficients, 14 over 7, and divide the radicands, so 10 divided by 5. So what we're going to get when we divide 14 by 7, this is 2, multiplied by the cube root of, and dividing 10 by 5, also gives us 2. So 2 times the cube root of 2. Second example, 20 root of 6 divided by 2 root of 2. The index values are the same, so we can divide the radicands. We will also divide the coefficients. So we have 20 over 2 times the square root of 6 over 2. This gives us 10 times the square root of 3. Now, you don't necessarily have to show this intermediate step, depends on what your teacher's preferences are, but I'm just showing it to kind of show the full process of what's going on here. Alright, now when we divide radicals, it's possible that we could get a radical in the denominator, similar to this next example. So we have 8 over 16. These square roots have the same index. They both have an index of 2, so we can divide the radicands. Alright, so what do we end up with? 8 divided by 16 is 1/2. 3 divided by 9 can be simplified to 1/3. So this is 1/2 times 1/3. 1/3 is the same thing as saying the root of 1 divided by the root of 3. So just applying the square root to the numerator and the denominator. 1 times the root of 1, well, this is just 1. 2 times the root of 3 is 2 root 3. Now notice that we have a radical in the denominator in this case. So what we're going to want to do is we're going to want to rationalize this denominator. We want to rewrite this expression in such a way that there is not a radical in the denominator. What's the purpose of doing this? Well, when we're adding fractions and we want to find common denominators in order to simplify them and things like this, turns out that having irrational numbers in the denominator makes it a much less useful prospect to work with those fractions. So very often in mathematics, you will be forced to rationalize these denominators. We're going to take whatever radical is in the denominator, in this case this is the root of 3, and we're going to multiply by the root of 3 divided by the root of 3. Why do we want to do this? Well, let's see what we end up with. In the numerator, we're going to multiply these two things. So 1 times the root of 3, well, that's simply the root of 3. In the denominator, we have 2 times the root of 3 times the root of 3. The root of 3 times the root of 3 is just going to give us the root of 3 times 3, which is going to be 3. You can see that if we multiply the root of a value by the root of a value, it's always going to give us that value. And note what happened. We no longer have a radical in the denominator here. So our final answer is root of 3 divided by 6. So we have successfully rationalized the denominator. Second example, we want to simplify this expression. Now these both have the same index value, so we can divide them. What are we going to get? So we have 9 over 5. Well, that's a fraction that does not simplify. Inside the radical, we can divide these two radicands because the index is the same. The index is 2. So that gives us 6 divided by 30. So now we have 9 over 5 times the root of 1 over 5, which is what we're going to get if I simplify the fraction under the denominator. So 9 over 5 times the root of 1 divided by the root of 5. Your teacher may tell you that this step is optional, which is 9 times the root of 1, which is just 9, divided by 5 root 5. Well, once again, we have an irrational number in the denominator. We have the root of 5. So we need to rationalize that irrational number. So we're going to multiply it by root of 5 divided by the root of 5. What's our final answer? Well, 9 times the root of 5. This is just 9 root 5. In the denominator, we have 5 times the root of 5 times the root of 5. That is just 5. So this gives us 9 root 5 over 25 for our final answer. Last example. We want to simplify this expression. Now, right away, what you should notice is that these index values are not equal to each other. We have a cube root in the numerator and a square root in the denominator. That means that we cannot divide these radicands by each other. 3 over 8, which is the two coefficients, also does not simplify. That being said, we must still rationalize this denominator. We have a root of 3 in the denominator, so we're going to multiply this by the root of 3 over the root of 3. Okay, what are we going to get? In the numerator, we have 3 times the cube root of 2 times the root of 3. Can we simplify these two radicals? We cannot simplify them because the indexes are not the same. So we cannot multiply those radicands together. We have to leave it in this form. In the denominator, we have 8 times the root of 3 times the root of 3, which is simply 3. At this point in time, before I simplify any further, note that we have a factor of 3 in the numerator. We have a factor of 3 in the denominator. Those two values will simplify. They will divide to give us 1. So our final answer is we're left with the cube root of 2 times the square root of 3 divided by 8. That is our fully rationalized expression. Okay, so there's a short introduction to dividing radicals. What we're going to be looking at in our next video is what if we have an expression such as this. How can we rationalize this? We're going to end up using something called the conjugate. And that is what is going to be the topic of our next video. So next up is going to be rationalizing expressions by using the conjugate.